Question 7. This is the moments question, and they've tried to make it look confusing, but actually what you have to do isn't ridiculously different to normal. Okay, so you have this diagram. You have one support, which is a cable, so there's going to be a tension in the cable. You have one support underneath here, so there's going to be a reaction force upwards supporting. You're going to have a downwards force for the mass of the beam. So it tells you the beam is a rigid uniform rod of mass 100 kilograms. So the uniform bit means you know that its weight acts in the middle. Okay. So question A says the wooden beam is held in horizontal equilibrium. Given that the support is capable of withstanding loads of up to 2000 newtons, show that the force exerted on the beam by the support satisfies the safety requirement, which is that it has to be at least 4 times those present in the architect's diagram. So whatever we work out from our diagram, we would need to multiply it by 4 and check that our answer has not gone over 2000. Okay, so I'm just going to draw the diagram again and label on all the different bits that we need. So we've got our beam, we've got a tension here, which we don't know what that is yet. We've got a support here, so we have a reaction at the support, and we know that distance is 0.2. Now we've been given 0.7, 3.5 and 0.2. Let's just work out where the midpoint of that would be. If we add those together, we get 4.4. So the midpoint is at 2.2 meters. Now I don't think the 3.5 is very helpful labelling it there. I'm going to split my beam and put my downwards weight force and make sure that I've labelled 2.2 to the centre. So if that's 0.7, then that gap there then is 1.5 there. And if that's 0.2, then this gap here is 2. And of course they add up to 3.5 as well. But it's more helpful to have all the individual distances labelled, I think, sometimes. And we were told at the start of the question that the mass was 100 kilograms, so that means we can label the weight force as 100 times 9.8, 100G. So that's the diagram I want to use. I'm going to work out the force exerted on the beam, so that by the support, so that's the R. Okay, so for A part I, we're going to find the R. So we're going to do this by taking moments. Okay, so you can take moments from any point you want, but it makes sense to choose a point where you get the simplest equation. Okay, so if you have 2 unknown forces and you're trying to work one of them out, choose this place where the other force is as your pivot point. Okay, so we're going to have our pivot point at where I've labelled sort of force T. Okay, so if you imagine that that is now free to spin, okay, with my finger holding it steady, you can spin it that way and the 100G is pulling it one way, or I can spin it the other way and then it's the R that's making it move that way round. So the idea of the moments is that the turning effect of the forces making it spin one way will be balanced by the turning effect of the forces making it spin the other way. So we're going to say that the turning effect, which is what we mean when we say the word moment, that is the force times the distance. So the turning effect of the 100G is 100G multiplied by a distance of 1.5 away from the pivot. And we're going to say that's being balanced by the turning effect of R, which is a distance in total of 3.5 away from the pivot. T does not get involved in the equation because it is zero distance. Okay, so if a moment is a force times a distance, this T has no turning effect if that's its actual pivot. Okay, so that's the equation, that's all. Let's just work that out. So we have 100 times 9.8 times 1.5, and then we're going to divide that by 3.5. And that gives us R is 420 newtons. If we multiply that by 4 for this safety requirement, that is 1,680, which is less than the 2,000. So therefore it meets the requirements. Okay. Part 2, determine which categories of steel cable in the table could meet the safety requirements. Okay, so the steel cable is the tension. So for part 2, we're going to find T. Now we could do exactly the same process and take my pivot point at R. Absolutely, nothing wrong with that. If you enjoyed creating the moments equation, you can do that. Actually, the simpler thing to do, once you only have one unknown force, is just to say, let's resolve vertically and say the forces up are balanced by the forces down. Now, this doesn't involve any distances. It's a different way of calculating T. You can just say T plus R are your forces up, 100G is your force down. So T is 100G minus the 420 that we worked out for R. 100 times 9.8 minus 420 gives you 560. So the tension in the cable is 560 newtons. If we multiply that by 4, we get 2240. Okay, so looking back at this safety requirement, okay, we don't want to have a steel cable with category C because it only goes up to 2000. We'd be okay with category B or okay with category A. So we want steel cables from category B or category A will be sufficient for the safety requirements in this case.